Welcome to another episode of Dave Does Math from Home. Today we're talking about section P5. In this one we are factoring polynomials. Factoring polynomials is not very easy. It's not as intuitive as doing the other operations as polynomials. In our last section in P4 we talked about adding, subtracting, and multiplying polynomials. You may have noticed that there was an operation that was sort of conspicuously absent from that list. We didn't talk about dividing polynomials. Dividing polynomials is honestly a bit of a mess, and that's why we split the division part. We made it separate from P4, and it actually spreads across P5 and P6 because there's a lot of different ways you can divide these things. So we're going to start with P5, and then when we have a pretty good handle on factoring these guys, then we're going to get to actually dividing them, and we're going to call that rational expressions. So look forward to that. But this is just sort of the preliminary division basics where we factor them. Before we get into actual factoring itself, I want to do just a really quick review of FOIL, because that's sort of the basics of the factoring plan. If you have something like 2x plus 4 times x plus 5, we have something like 3. No, I don't want to do 2's and 3's in here yet. Let's just do the x plus 4 times x plus 5. Here we'll do x plus 7 times x plus 9. And here I'll do x minus 3 times x minus 4. Here we'll do an x plus 10 times x minus 2, x plus, we'll do another minus one, I guess. Do x minus 6 times x minus 6. And then down here we'll do an x plus 1 times an x minus 1. Okay. So this is the really quick FOIL review. When we do this one, we're going to get an x squared from the first piece. The inside and the outside will be 4x and 5x, so that'll combine into 9x. And the last will be 20. Here, we're going to get an x squared. 7x and 9x should get us 16x. And on the back end, we'll have a 63. Here, we have an x squared. Negative 3x, negative 4x should give us negative 7x. And then these two combined should give us a positive 12. Over here, we have an x squared. Positive 10x and negative 2x will give us positive 8x. And then on the back end, we're going to have a negative 20. Here we'll get an x squared. Negative 6x and negative 6x is negative 12x. And then when you multiply these together, you should get positive 36. And down here, we're going to get our x squared. We're going to get positive x, and negative x is 0x. And then multiply these two guys, and we'll get a negative 1. So this is the quick FOIL review session where we do a bunch of really simple FOIL problems really fast. And we do this because I want to talk about the patterns that we see here. I want to get a different marker for it. So one of the patterns I'm hoping that we can see in all of these answers is that they all have an x squared. The x squared is just there, it's hanging out. We're not really fussed about the x squared. The linear term, let's talk about the constant term next. 20 is 4 times 5. 63 is 7 times 9. 12 is negative 3 times negative 4. Negative 1 is negative 1 times positive 1. 36 is negative 6 times negative 6. And negative 20 is 10 times negative 2. So that's one of our patterns here. The constant term is always the product of these two terms. 7 times 9 gives us the 63. -3 times -4 gives us the 12. -6 and -6 gives us the 36. Constant term is always the product of those guys. The other pattern I want to talk about is this middle number. The 9 is 4 plus 5. The 16 is 7 plus 9. The -7 is -3 plus -4. The 0 is -1. Don't do that marker. Is -1 plus 1. That's our 0x here. The -12 is -6 plus -6. And the 8 is 10 plus -2. So, one of the reasons that I'm talking about these patterns is you can use these patterns to do FOIL more quickly than before. So you can, next time you see something like this, you can think about, I mean, kind of like what I did, where I skipped. Usually when we do FOIL, we get the 4 terms, and then we combine like terms. And I skipped that step on all of these. I was just looking at the x squared is always the first term, 4x plus 5x is always the middle term, and then 4 times 5 is the last one. So one of the reasons I'm talking about these patterns is because hopefully they'll help us do FOIL faster. The bigger reason I'm talking about these patterns is because I want to do FOIL backwards. That's what factoring is. So I want to take away all of these things that we know the answers to. If I can, that blue is hard to erase. I want to do FOIL backwards. I want to start with something like x squared plus 5x plus 4. And I want to see something like x squared plus 10x plus 21. And I want to see things like x squared plus let's do 12x plus 20. I want to take each of these quadratics and I want to split it into two binomials. So x plus something and x plus something else. X plus something, x plus something else. I know that this should work. I've got this x squared. Like the first pattern we noted in all of these is that they all start with x squared. So these things all start with x squared, so I should be able to do this thing to them. So that's the plan here. I just have to figure out two numbers that, according to this pattern, these two numbers need to multiply to give me 4, and they need to add to give me 5. These two numbers, this might be the easiest pair. I need to think of two numbers that multiply to give me 21. I'm sorry, I mixed up my colors. I was going to use blue for the adding. Okay, there we go. I need two numbers that add to 5 and multiply to 4. I need two numbers that add to 10 and multiply to 21. Here I need two numbers that add to 12 and multiply to 20. So I think this middle one is probably the easiest one. 21 doesn't have a lot of factors. And I suggest you sort of always start with the multiplication piece, because in general, finding factor pairs, finding two numbers that multiply to give you something, is a lot more restrictive than finding two numbers that add to give you 10. So like if you start with this adding piece, you might start with like, well, 5 plus 5, 6 plus 4, 7 plus 3, 8 plus 2, 9 plus 1, 10 plus 0, -1 plus 11, -2 plus 12. Like you could go on forever finding pairs of numbers that add to 12. But finding numbers that multiply to give you 21 is actually pretty restrictive. We could do 21 and 1, or we could do 7 and 3. And those are pretty much it. So 21 and 1 would add up to 22, so that we don't want to do that. But 7 and 3 seems like a good bet. If this is 7 and 3 and this is 7 plus 3, then this quadratic should factor into x plus 7 times x plus 3. And that's what we're doing. We're trying to utilize this pattern that appears whenever we FOIL something to FOIL something backwards. And that's the FOIL process. If we're doing 20, things that multiply to 20 could be 4 times 5, which doesn't add to 12. Could be 20 times 1, doesn't add to 12. Could be 10 times 2. That does add to 12. So 10 times 2, and this is 10 plus 2, which means that the factors are x plus 10 and x plus 2. And that's all there is to this, in terms of the basics anyway. These get a little more exciting as we go. Here we have things that multiply to 4. Could be 2 times 2, it's not going to work, or 4 times 1. 4 plus 1 will give us that 5. So this is going to be an x plus 4 and an x plus 1. You might notice that for these three examples, the order doesn't really matter. This could be an x plus 4, x plus 1, or it could be x plus 1, x plus 4. That's fine. 7 and 3 could be 3 and 7. 10 and 2 could be 2 and 10. When everything is positive, the order is not important. But things will start to get a little bit more interesting when we make some pieces of this guy negative. So let's take a look at that. Let's see what we can do with x squared plus 2x minus 8. And let's also see what we can do with x squared minus 3x minus 28. And let's also see what we can do with x squared minus 11x plus 30. So with these quadratics here, all of these have negatives in different combinations of places. This one, well, first of all, the x squared is still positive. So that's good. We don't have to do, there's other slightly more interesting techniques you can use when you have a number in front of the x squared. And we're going to talk about those in a bit. But for now, we're still doing the x squared piece is positive. Here we have positive, negative, 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 positive. So this is contrasted. These first three were all positive, 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 positive. These are the other three situations you can come up with. I'm going to start with this one right here, the one on the bottom. When you have a positive number here and a negative number here, it means that both of your factor pieces have to be negative. The only way you can get a positive number on the back end here is by multiplying two positive numbers together or multiplying two negative numbers together. And if you multiply two positive numbers together, you're going to get a positive number here. So the only way you can get a positive on the back end and a negative in the middle is if they're both negative. You multiply the two negatives together to get this positive, and you add the two negatives together to get this negative. So when they both have the same sign, that's usually makes this easier for us, because then we still don't have to care about order like much at all. So we just have to find two numbers that are going to multiply to 30, and that when we combine them, we're going to get negative 11. So I think that that's probably just going to be negative 5 and negative 6. 5 and the 6 will be your, those will multiply. Negative 5 and the negative 6 will multiply to give you your 30. Negative 5 and negative 6 will add to give you your negative 11. So the negative in the middle and the positive on the back end situation is a lot like this situation, where you're looking for two numbers that multiply to get this and add to get this. Here we make them both positive, here you make them both negative. Not a lot of difference there. When the back end is negative, that's what makes it a little more tricky, because now we need to get a negative on the back end. We need to have an x plus in one of these and an x minus in the other. And now, abruptly, it matters which one is which. So here it could be x, when we did these, we talked about how the order doesn't really matter. It could be x plus 7, x plus 3, x plus 3, x plus 7. You can flip these guys around and nothing changes, because everything is positive. You could flip these guys around and nothing changes. Doesn't matter if it's x plus 6 and x minus 5. Here, whatever two numbers you come up with that multiply to give you 28, one of them has to be positive and one of them has to be negative, and it matters which one's which. So these have like an extra little step of thinking hard about them that we have to do. So first, let's figure out which numbers can multiply to give us 28. We could use, I think, 7 and 4, 14 and 2, 28 and 1. I think those are our only three pairs. We got three sets of options for this 28. One of these numbers is going to be positive and the other is going to be negative. So when we combine them to try and get 3, or negative 3, I mean, we have to subtract them. So we could do like 14 minus 2 or 2 minus 14. Neither of those will get us a 3. We could do 28 minus 1 or 1 minus 28. Neither of those things will get us a 3. I think we're going to have to use the 4 and the 7 to get the 3. But it matters which one's which. If we do positive 7 and negative 4, we're not going to get a negative 3 out of that. The only way we can get a negative 3 is by doing a negative 7 and a positive 4. So this is what I mean when I say the order matters for these guys. X plus 4 and x minus 7 will combine to put a negative 3 here. X plus 7 and x minus 4 doesn't work. That's no good. This one does work here. That one's good. So we can imagine doing the same thing up here. If we want a negative 8 here, we're going to have to use either 8 and 1 or 4 and 2. The 8 and the 1 are probably not going to be able to get us a 2 here, so we're probably going to have to use the 4 and the 2. When we combine them, we want the result to be positive. So I think we want the 4 to be positive and the 2 to be negative. And that will get us that 2 that goes here. Yeah. 8 minus 4 and 8 plus, or sorry, x minus 4 and x plus 2 won't work. Has to be positive 4 and negative 2. That is my introduction to factoring as sort of the reverse FOIL situation. There's more to talk about with respect to factoring, and I'm going to put it in another video because we're already at about 20 minutes. So stay tuned.